Let's practice some integrals that require U substitution. Let's start out with this example. Let's find the integral of x squared plus 1 over x cubed plus 3x dx. Now when you first look at this integral, hopefully you notice it's a quotient, and remember we don't have a quotient rule for integration, so that means we should probably try U substitution. I have a quadratic function in the numerator, a cubic function in the denominator, so that cubic function is going to have to be my u because the quadratic will be its derivative. So u is equal to x cubed plus 3x. And then the derivative of u, the derivative of that, would be 3x squared plus 3 dx. Now if I go back and look at my integral, I don't have 3x squared plus 3, I only have x squared plus 1. But if you notice, I could factor out a 3 over here from my du, and we get 3 times x squared plus 1 dx. So all I need to do is multiply in a 3 over here in my integral times 3, and I'm going to multiply a 1/3 in front to balance out or cancel out that 3. So now here is my u, and then all of this is equal to the du. So we're ready to rewrite the integral. This is equal to 1/3 times the integral of 1 over u du. So now we have this integral in a form that matches one of our rules. The 1/3 out in front, of course, it's just going to stay. And then the integral of 1 over u du is the natural log of the absolute value of u. And since this is an indefinite integral, we're going to put plus c at the end. And then for our final step, we need to substitute back in for u, natural log of x cubed plus 3x plus c. And that would be your final answer. Let's look at another example. This time, let's take the integral of 3 minus x to the 4th dx. Now in this problem, if you look at what we have here, we've got a composite function. I have the function 3 minus x. It's being raised to the 4th power. And if we were doing derivatives, that would of course require the chain rule. But since there's no chain rule for integration, we're going to use U substitution. See if we can change the way this looks. The U is going to be the inside function, which in this case is 3 minus x. The derivative of U would be -1 dx. Now if I go back and look at my integral, I don't have that -1 there, but of course we can multiply it in. I'm going to stick it here in the front. And if I multiply -1 on the inside, I need to also multiply -1 on the outside to balance it out. So this 3 minus x, that's my u, and then the -1 dx, that is my du. So I'm ready to rewrite this integral as -1 times the integral of u to the 4th du. So now that matches one of my integral rules. We can do this integral. The -1 stays times, and the rule is going to be, it's our x to the n rule, which is the integral of x to the n is equal to x to the n plus 1 over n plus 1. In this case, u to the 5th over 5, and then this is an indefinite integral, so of course we're going to put plus c on the end. Finally, we need to substitute back in for u, so I have -3 minus x to the 5th over 5 plus c, and that's our final answer. Let's look at one more example. Integral of sine of the natural log of x over x dx. Now, on first glance, this one looks pretty challenging. We've got a quotient. I have a natural log inside of a sine function, so I've got a composite function. Obviously, we need to do something to rewrite this. We need to use U-substitution. And remember that your U is often going to be an inside function. In this case, natural log x is on the inside of the sine function. So let's see what happens if we choose that to be our U. U is equal to the natural log of x. The derivative of that, derivative of natural log of x, is of course 1 over x dx. Now maybe this integral over here makes a little more sense. The natural log x, that's our U. And then notice we have the 1 over x dx as our du. And so we're ready to rewrite this function, this integral. It's equal to the integral of sine u du. And of course the integral of sine is negative cosine u, and this is an indefinite integral, so we're going to put plus c. And final step would be to substitute back in for u to make it negative cosine of ln x plus c, and that's your final answer.